So we need to find minimum, maximum, and then we need to find Q1, Q2, and Q3. And then we need to answer for questions, does the data contain any outliers? And next things will construct a box plot for the given data. Okay, first question, tell me please, what is the minimum, what is the maximum in this set? And write please in the chat line 2 numbers, what is the minimum, what is the maximum? Morning. Please let me know what is the minimum, what is the maximum for the set in the figure 1. You can see dots on the figure 1 and tell me please, what is the minimum, what is the maximum? Okay, thank you very much. And I don't know, to see, for example, outliers from this data, yes, it's difficult. It's possible that, yes, we can make this decision before calculations, yes, that, for example, maybe 0 and 10 looks like maybe they are outliers, but we really cannot say this. We need to calculate special values, yes, and see, compare these values, yes, with our original data. So what we want to do now, we need to now, to find Q1, Q2, Q3, it's better to have frequency distribution. In this case, please make frequency distribution. What is the frequency distribution? First column is xi, when you put all different numbers of xi. In our case, it's 0, 4, 5, 6, 7, 8, 10. And second column, put frequency, fi. And then we'll check this together, okay? Please make frequency distribution for this data. 2 columns, frequency distribution, 2 columns, xi and fi. I'm going to do this too, and then we will check together. Okay, now we're going to check this. Yes, I share the screen and see what do you have. Yes, look, you have your xi, all different values, 0, 4, 5, 6, 7, 8, 10. And second column, it's fi, yes, it's, and frequency 1, 1, 3, 3, 3, 1, and 1. No, and total frequency is 13, so we have 13 points. Yes, we have 13 points. No, and now to calculate, this is frequency distribution. First 2 columns is frequency distribution. To calculate Q1, Q2, Q3, it's useful will be to have a commutative frequency. So we now make another column, yes, and calculate and find, please, this commutative frequency. So it will be 1, 2, 2 plus 3, 5, 8, 11, 12, and last must be coincide with the number of the sum of the frequencies, so 13. So now we need to calculate Q1, Q2, and Q3. So n is equal to 13, so we have 13 points. No, and okay, minimum you told me that it's 0, maximum is 10, and now Q1. No, and n is 13. We have 13 numbers. No, and now we calculate Q1. How we calculate Q1? First, we find the index, yes, n plus 1 over 4. N is 13, so 13 plus 1 over 4 is 3.5. No, and now, to find Q1, I need to take 50% of x3 plus 50% of x4. Or in other words, I can write like median in this case. Yes, I can write differently. 50% of x3 plus 50% of x4. Or you can write this as x3 plus x4 divided by 2. This is the same things. So we're going to the table and see where is x3, where is x4. And we go for the last column. X2 is x2 is too small for us. We need to find where is x3 and x4. x3 and x4 will be in this row. Starting from 3, 4, and 5, yes, will be in this row. So x3 and x4 is equal to 5. So it's equal to 5 plus 5 over 2, so it's equal to 5. Okay. In this case, we in one row, which correspond to the number of the 5. So this is how we find Q1. Please try to find now Q2 yourself. What is the value of Q2? And then we'll check together. Please try to find the value of Q2. Okay, again, I will remind you what is the cumulative frequency. Yes, it's frequency on the current step and of all frequency up to current step. For example, yes, for example, how to calculate again this frequency? We start from beginning, yes, frequency on the current step is equal to 1. It's equal to 1. Then when you're going to the second row, frequency at the current step is 1, and previously you're going for looking for the previous row is 1. 1 plus 1 is 2. Then you go to the next, where is number 5. Frequency of the current step is 3, and accumulated frequency, what is below this, yes, row is 2. So 2 plus 3 is 5. So and so on. So it's all frequency up to the current step and plus frequency of the current step. So you accumulate them, yes, you add them together. And last number you consider 13, yes, it corresponds, yes, to the number of the numbers, or number of the sum of all frequencies. Did somebody find Q2? Or median, in other words? And what is Q1, Q2, and Q3? Yes, it's quartiles. Yes, it's called quotes. You can use word quotes. Yes, if you have data. Yes, if you have your data. Yes, I'll roughly explain you. Yes, if you have your data, Q2 divide data on the halves, and this is first quarter. Yes, Q1, and this is Q3. So this is this number. Yes, this is how we divide our data. Yes, in the for example, in the quartiles is quarter. Yes, Q1 is first quarter, Q2 is it's 50%. Yes, Q1 is 25 quarter, Q2 is 50% or median, and Q3 is 75%. Yes, all called third quartile. And the rules to find, yes, to find them. Okay, yes, thank you. Yes, Nikita, it's 6. Yes, median. To find median, okay, this is the same rule for them. For Q1 is we need to find n plus 1 over 4. For Q2, we need to find n plus 1 over 2. So n in our case is 13. 13 plus 1 over 2 is 7. So now I'm going to my last column and see where is x7. So where is 7? Look, from 3 to 5, I'm in the row, in this row, and 7 and 8 in this row. So my element x7 is equal to 6. So this is median. So it's equal to, so Q2 is equal to, I can write this here, x7, and is equal to 6. We did this in last time. Yes, in the lab 6 is the same thing. And then third quartile, yes, n plus 1 multiplied by 3 divided by 4. You can see 3 was 4, 75%. Yes, this is where it came from. So 3 n plus 1, 13 plus 1 divided by 4. If you find this number, Q3 will be 10.5. So it's not x10, it's not x11, it's somewhere between them. And if you remember in the lab, yes, it was percentage 75. It's a little bit more difficult to find. In this case, it's very easy to find Q3. Yes, it's exactly between 10 and 11. Yes, so it's x10 plus x11 over 2. Or general rule, yes, you need to consider where is this number belongs to, yes, and rewrite this correspondingly. So going and see what is x10 and what is x11. Going to our table, cumulative frequency. Look, and again, in our case, it's 9, 10, and 11 in this row. So it corresponds 10 and 11 is equal to number 7. So it will be 7 plus 7 over 2. So it will be equal to 7. And please remember how we did this in general. Remember? And for example, look, if you have if you have here, for example, in our case it was 50%. It was, in this case it was good. But imagine that I have here xn, not m. I put m. Here I have xm plus 1. And somewhere I have this, my point is, no, let this will be, let, for example, let q3 is equal to 10.1. I will remove now this 10.1. So in this case, it's my, not Q3, it's index for Q3. Yes, it's not Q3, it's not Q3, indices for Q3. Yes, Q3 is equal to a number. We don't know. It's when we calculate Q3, yes, we calculate the value. This is 3n plus 1 over 4. Imagine this for Q3, we have 10.1. So this is 10, this is 11. So 10.1 belongs to the, yes, interval from 10 to 11. In this case, how to find here Q3, yes, Q3. You can see that distance here, you can see the distance here, 0.1, and here 0.9, yes, to 11. So it's more close, my number 10.1 is more close to the number 10. So in this case, Q3 will be equal to 90% of x10 plus 10% of x11. In the picture, you can see differently, yes, but you can use logic here, yes, that its number 10.1 is more close to the 10. So it will be 90% of x10 and plus 10% or 0.1 of x11. No, in our case, in example, it's both numbers was symmetrically between 10 and 11. Yes, it was 50%. So in this case, we check half of some of these numbers. But in general, yes, you put some weights to the numbers x10 and x11. So any questions? Please ask if you have any questions. Now we move on to the second part of this. So this was only start. Yes, we find this 5 number summary. So this is first things we can say that it's first. I will repeat one time once more. Look, in our case, for example, Q3 is 10.5. When we calculate Q3, in our case, again, in our case, when we calculate Q3, we find that we need to take, we need to take x 10.5. Yes, we find this number x 10.5. No, and how to find this number? Yes, when we calculate Q3, first we find the value. This is value 3n plus 1 over 4, and it's equal to 10.5. So this is index, yes, index for the x. But what is this x 10.5? Yes, I don't know. I know what is x10. I know what is x11. Yes, and so on. But what is 10.5? Or in my example, artificial here example, what is 10.1? Yes, what is number this? So in this case, 10.5 is exactly yes, is exactly between 10.5, between two numbers, 10 and 11. In this case, look, here 50%, 0.5 or 50%, and here 0.5. So to find Q3 in our case, we check, what we check? X10, you can say 50% plus 50% X11. Or in other words, it's X10 plus X11 divided by 2. Yes, if you multiply and divide by 2, you have this formula. This is formula for our case. In general case, when you, for example, have this, when you need to find how to find X 10.1, yes, here. In this case, you put these two numbers and see that, of course, 10.1 is more close to the 10, yes? Distance between them, 0.1. And far away for 11, yes, 0.9. So 10.1 is close to the number 10. So because it's close to 10, in this case, I need to check majority of X10. In this case, 0.9, it came from, of course, 1 minus 0.1 is 0.9. So 0.9 multiply X10 plus 0.1 multiply X11. Okay, it's very important to put right weights. And how we decide this, we draw this picture and see this number 10.1 is close to 10. So I will take not 0.1, I take 0.9 of X10 because it's close to 10. And because it's far away to 11, I will take only 0.1 of X11. Okay? Any questions? Okay, now we need to discuss do we have outliers or not. To find outliers, we need to find the values. First, we need to find IQR, which is equal to Q3 minus Q1. In our case, Q3 we find is 7. So Q1 is 5, yes? So IQR is 2. Next, we need to find value Q1 minus 1.5 multiply IQR and Q3 plus 1.5 multiply IQR. So Q1 is 5 minus 1.5 multiply 2. It will be equal to 1.5 by 2, 3. 5 minus 3 is 2. No, and next value, Q3 is 7 plus 1.5 multiplied by 2. 7 plus 3 is 10. No, and now we need to find outliers. We see for the numbers xi, which is less than 2. We see for the numbers, or we see for the numbers xi, which is greater than 10. This is definition of outliers. They below first value and they up the bigger than second value. Now and go for our table and see. Do we have numbers less than 2? Do we have? Please let me know. Do we have the numbers in our table less than 2? Yes, thank you, Nikita. Yes, we have, yes, it's 0. And do we have numbers greater than 10? Thank you, Shakir. No. So, in this case, conclusion that we have one outlier, yes? So we have from here, we have that we have number 0, yes? So, we have one outlier. Yes, we have one. 0, which is 0. Okay, we don't have none here, but we have one outlier here, 0. No, and now we need to draw the box plot. Yes, box plot, and finish this the first question. Okay. Okay, my numbers, I will use the scale, 2, 4, 6. You can use different scale, of course, 12. And now I will draw my box plot. First, of course, I will draw Q1, Q2, and Q3, and draw the rectangle, yes? Okay, what is Q1? 5, and Q3 is 7. Okay, 5. Sorry, Q1 is, yes, 5 and 7. 5. Where is 5? Roughly here. 5 and 7 between them, 7. Okay, and median is 6, Q2. So this is easy. Q1, Q2, and 3. So this is Q1, Q2, and Q3. Now, because I have one outlier, 0 will be here. Yes, 0 will be here. One outlier. And because I have one outlier, my set now, if I remove this 0 from my set start from the 4, from 4. In this case, this now my new minimum is 4. Yes, 4. And then I don't have outliers above the chain. Yes. In this case, chain still will be maximum. Yes, in my set. So viscous and this. And this is this. Don't forget about this fat dot. Yes, this is the box plot. Q1, Q2, Q3, and viscous. Any questions? In this case, now we move on to the second question. Please look for the second question. Look for this histogram. And for this histogram, we have this 5 number summary in the following table. You can see. No, and now to answer our questions, yes, we need to calculate. No, Q1, Q2, and Q3 we know. So we need to calculate IQR. Please tell me, what is the value of IQR? IQR is difference Q3 minus Q1. What is the Q3 minus Q1? Please tell me, what is the IQR? Yes, thank you, Clinton. Yes, it's 11. So now we know the value of IQR. Please, now to find value Q1 minus 1.5 multiply IQR and Q3 plus 1.5 IQR. Please find for me these two values. For the given data. Please tell me, what is the value Q1 minus 1.5 IQR? What is this value Q1 minus 1.5 IQR? I have different answers. Somebody else? What is Q1? 31. Okay, sorry, guys, I put 13. Okay. 1 second. I put in my notes 13, not 31. Okay. 31 minus 1.5 multiply that. Okay, yes, thank you very much. 14.5, yes. Thank you, Nikita and Shakira. Yes, it's 14.5. And now, please go for the data, for the histogram, and tell me how many low outliers are in the data. So we need to see on the histogram and calculate how many you have data less than 14.5. What do you think? Do we have outliers here? Yes, it's a little bit, example is not so obvious, yes, for me either. Yes, but look, because it's, we assume that, I mean, 14.5, yes, it's, no, it's 15 almost, yes. And if you can see in your histogram, yes, that we have one outlier, each box, yes, each rectangle, small rectangle, yes, with height, yes, for example, if you calculate how many of them, you have 6 plus 5 and 5, 16. So, yes, each small rectangle in this picture is person. So, and because we have this on the left-hand side, we have this person from 10 to 15, and height is 1, yes? So I assume we'll check this and tell this one outlier. Do you understand me? This is most left rectangle on the picture from 10 to 15, yes, and height is 1. This is one person. And so this is one person will be outlier. So answer here is one outlier. Please now try to find second value, Q3. Why? Okay. Q3 plus 1.5, yes, IQR is 58.5. Yes, thank you, Michael. No, and now look for the histogram. Do we have any people, yes, which is greater than 58.5? Do we have any outliers? Yes, thank you, Shakir and Michael. Yes, you can see that one rectangle, yes, most right rectangle, yes, is after 60, yes, which is after 60, it's outlier. Yes, so we have one outlier here. You can see that for the Upper bound is obvious here, yes, type of it's because 58.5 it's between, but to the left hand side it's a little bit accurate, yes, but still one outlier we have one outlier. Okay, thank you. Now we move on to the next question and we discuss with you again the solution for the next question. Question number 3. Okay, maybe you cannot see this. Okay, question number 3. Please, you have this box plot for data, and we need to choose one of the sequences which corresponds to the box plot. Okay, now first of all, I will go for, first of all, for example, I will investigate maximum and minimum. So minimum is 4, you can see, yes, maximum is 14. And which sequence will definitely doesn't work for this minimum and maximum? Which sequence, please choose letter, yes, and tell me which sequence, A, B, C, or D, does not work for this plot. Only based on the minimum and maximum argument. Yes, thank you. You can see that C, yes, it's because minimum in the C is 2. So this sequence gone. Okay, now we left with A, B, and D. Yes, you can see that they start and finish with 4 and 14, so it's no information for us. Now we need to play with median mode, with median Q1 and Q3. Look, Q1 is 7, yes. Q2 or median is 9, and Q3 is 12. And 7. And again, we cannot really make this decision still yet. But again, I will start now with median. Median is easy because it's in this case, what is median? Median is 9. In this case, first I calculate how many numbers do I have in sequence. Please tell me how many numbers in each sequence. No, the same number in each sequence, calculation 1, and tell me please, how many numbers in each sequence, A, B, C, or D? I assume it's the same number, and how many? Yes, thank you, Anis. Yes, we have 12. So if we have even number, n, how we can find median? What is the rule for the median? If n, yes, was odd, we have one rule, yes, but if n is even, we need to take average of 2 numbers, yes? I remind you now. You probably remember, of course, but still. Okay, n is 12. So what is the median? Median in this case will be x11. Oh, sorry, which x11? Half. What is half? Half of 12 is 6, yes? x6 plus x7 divided by 2. So tell me, please, from the box plot, what is the value of median? Median is Q2. What is the value of median? From the box plot, what is the value of median? You can see this in the box plot. What is the value of median? Tell me, please. Yes, thank you. Median is 9. Very good. So median is 9. Now, please calculate for A, B, and D median. Find, please, x6 plus x7 over 2 for each sequence, A, B, and D. Yes, I would like to find x6 plus x7 over 2 in each sequence. Maybe we split. Okay, Nikita, please calculate for the sequence A. Clinton, calculate for sequence B. And maybe Anas, maybe calculate for D. And Shakira, choose any what you want for the checking. And everybody, please check A, B, or D sequence and calculate for yourself and find values x6 plus x7 over 2. Okay. Yes, yes. Please, the question. Okay, we know that sequence C doesn't work because minimum maximum. This is easiest arguments. Always start with easiest maximum minimum, and then what is left we need to investigate more, and then play with median. B H.5 B. Yes, B is H.5. And calculate some for other sequences. Nikita, if you have time, yes, calculate for all of them. B, okay. What about A and D? Did somebody calculate for them? A is 9, no, and D left, yes. So you can see that, okay, we check, yes, X, 1, 2, 3, 4, 5, 6. H plus 10 over 2 is 9. B, H plus 9 over 2 is H.5. And D is 10. So answer is A. Answer. Okay, answer is A. And not C, since minimum is equal to 4 and not equal to 2. This is for you, for you. Remarks, yes? Oh, sorry, I didn't share screen. Okay, you can see that only case A, only sequence A is answer, yes, because median is 9. We see from the box plot and we find that it's for the case A. Okay, any questions? Now I would like to consider another, I would like to stay up to 1 o'clock, yes, and then maybe we'll have a break if you want, yes. But I would like to finish this. We need to consider 2 more questions. Okay, at least, because Okay, next question. Please look for the 3 different class groups and for the 3 box plots. They're in the same graph. Maybe I can do bigger, or you can maybe do. Okay, I would like to ask you, which group appears to have the highest median mark? Remember, please, yes, that median, yes, it's line in the middle of the box plot, on the middle line, sorry, in the middle of the rectangle. Please tell me, which group have highest median mark? And it's a nice question. It's very easy. Yes, you can see that graphs. Yes, second group. Yes, somebody else. Yes, second group. Yes, everybody agree. Second group. Yes, group 2. Yes, because median roughly it will be 63. No, roughly. Yes, for the group 1, for example, it's 35, and for the group 3, it's 52. I'm guessing. Yes. So highest, yes, for the orange group 2. Second question, which group appears to have most varied results? What this mean? It means which box has biggest height or longest box, yes, if it's in another axis. Which box has yes, biggest height in this picture? Which box? Which rectangle? Yes, group 3. Thank you very much. Yes, it's absolutely right. Yes, and you can check if sometimes group are too close. Yes, again, go project this to the y-axis and see, for example, green box roughly from the 45 to 80. Yes, 80 minus 45. So this length height is 35. For yellow, from 45 to 70, it's 25. So it's obviously, yes, green has most height. Very good. No, and last, which group appears to have the least varied results? And again, yes, it's group 1. Thank you, because height is smallest. Yes, the same idea, only in different direction. Very good. In this case, and now I would like with you to calculate at least. We go to the question 5 together and try to find, this is last exercise for today, yes, try to find standard deviation for the population. Please, we go for the question 5a. Please, you need to know how to calculate this, yes, and we try to find the standard deviation. Question 5a. Okay, our sequence is H, 9, 11, 14. So to find standard deviation, we're talking about population. So we will have sigma is equal to, we will have in denominator n. If you talk about sample, we're not talking about sample because no time in your course at all. In this case, n. If it's sample, it will be n minus 1. In difference, we talk about population, so in denominator is n. In the numerator, we have sum of I from 1 to n. Sorry if it's, and here we have xi minus x bar square minus mean. Yes, sometimes for mean. This is really for sample. I don't know which notation is David use for the population. It's usually mu. Yes, population. And I don't know, do you use x bar? Tell me please, do you use x bar or mu? Mu. Sorry. It's the second one. So you use mu, yes? Because for the population, you usually use mu. Okay, second one, mu. Okay. Oh, sorry. Okay, please stay with me a few more minutes. Okay, mu. So in this case, I will rewrite that if you use mu, that I will not, we will use only one notation that not mixed in your head. Sorry, xi minus mu. Mean mu. How to find mu? Mu is mean, yes, sum of all xi divided by n. So now in place we find now. We have h plus 9 plus 11 plus 14 divided by 1, 2, 3, 4, 5. Divided by 5. So this is how we find mean. Yes, mean of population, sum of all data divided by n. We played with this formula before. Yes, mean is the same formula. So if we find this value, it will be equal to 16 and 14, it's 30 plus 20, 50, so it's equal to 10. So it's equal to 10. Mu is equal to 10. Now, to find standard deviation, what we need to do, yes, we need to find this square root of this expression, n under square root 2, n is equal to 5. So now I check all elements of my data. First element is h, minus mu, minus 10 square, plus second element, h minus 10 square, plus next element, 9, 9 minus 10 square, plus next, 11 minus 10 square, and plus next element, 14 minus 10 square. 14 minus 10 square. Everything is under square root, yes? So this is expression under square root. No, and this is everything under square root. No, and if you calculate this value, if I calculate this right, then it's roughly square root of 5.2 is approximately 228. So you can please check, yes, and that that standard deviation is equal to 2.28. And sometimes it's useful to use table. Yes, I will show you how you can do this. Maybe it's useful and easy for you to use table. For example, look, what is table? First column is xi, second column is mu minus xi. No, maybe without square. It depends how much calculation do you want to do. Yes, maybe only two columns. Yes, xi, for example, h 9, 11, 14. Of course, if you want, it's total. Yes, total. Look, you can find from this table. Why this table is useful? Yes, because you can find. I will move this because 1 second. You can find mu from this table too. Look, totals here. If you find sum of all xi, it will give you what we count today, 50. Yes. Then mu minus xi. Then you can find easily or use a table. Use a table. This is or. Yes, or use a table. And to find mu, yes, it's sum of xi divided by 5. So sum of xi is here, 50. 50 over 5 is 10. So you can easily to find this mu. Now 10 minus h. 10 minus h is 2. No, and so on. It's 2. Mu minus it's 1 or minus 1. 10 minus 1. 10 minus 14 minus 4. No, and now square these numbers. 2 square is 4, 4, 1, 1, and 16. No, and now find this sum. Okay, and 4 and 4, it's h, 10, 26, if I'm right. 26. No, and now to find standard deviation, yes, formula the same, yes. Sum of mu minus xi square over n. So in my case, it's 26 divided by 5. No, and as I told you, it's square root of 5.2 or 228. So You can use Chable. If you understand better Chable, that you can use Chable. If not, use directly substitute and find the standard deviation. Okay, we are going to have now break for 10 minutes. And before break, do you have any questions? Or maybe you don't have, sorry, I didn't ask you, maybe you don't want, do you want break? Sorry, I assume that you want break. Do you want break? Yes, okay, we're going for break. Okay, I see you in 13. Yes, Michael, I understand that no questions, yes. Thank you very much for your response. Okay, we have a break and see you 13:13. Okay, everybody welcome back. Wait for 1-2 minutes and join the class. Okay, lab 7. Yes, what do we need to do here? Again, as in previous yes lab, we need to calculate a 5-number summary for data. Yes, so Q1, Q2, Q3, minimum, maximum, and construct a box plot and decide do we have any outliers or not. Now again, for outliers, you need to find, like we did in exercise today, yes, Q1 minus 1.5 IQR and Q3 plus 1.5 IQR, and see do we have below first number or above the second number. Okay, will we try to do something again in the, what do you think, in the Excel, or you try to do yourself? Or you want me to play with some data in Excel? Please let me know. Okay, I will start with question 2, 3 because they are type of faster, will be easier, yes, shorter, because they are shorter. And then we move on to again to the Q1, Q3, to question 1. So we're going now to the, okay, 1 second before we go. We're going to Excel now. Okay, let I have 2 groups, for example, I don't know, group 1 and sorry, and group 2. No, and just pick up some numbers, I don't know. No, and group 2. Okay, you can see that I have different numbers in the groups, 1 and 2. So I have these 2 groups. First of all, I would like to construct, yes, this box plot using these 2 groups, yes, and okay, we color these 2 groups, going to the insert, and now looking for the box and whiskers, yes, this I have it here. So you can see that my box chart is here for 2 groups, and I don't have, now we will discuss what I have here, yes, with you together. Look, I have this, yes, 1 box plot, yes, and now I will compare these two charts. And I need, for example, decide which group has the highest median mark. Now you can see from my box plot that highest group 2, yes, has orange group, yes, I call this group 2, has highest median, yes, it's roughly, I don't know, 40, sorry, I couldn't see this, I couldn't see numbers, too small for me. I try to see your chart, maybe questions. So you can see that from my chart, yes, that orange group has highest median. And which group has the most variable data? Again, orange box has height bigger than blue box, so orange box has more variable data. No, and okay. For example, group 2 has the highest median and the most variable data. Okay, from the graph, you compare them together, yes, and you can see this, that, yes, in this case, when you have 3 groups in the lab, yes, and color 3 groups, and find again this box plot, and viscous, and they will be in the same axis, yes, and the same graph. And then you can see this graph and compare them, who has, highest median, lowest median, yes, most variable, and so on. No, in my example, it's like this. Now I will show you how to calculate, for example, for group 1, it's question 3 in your lab, how to calculate standard deviation. Okay, next question, standard deviation. Standard deviation. Okay, for standard deviation, for group 1, for example, we will use function, look, we will use function standard ST deviation P. Where is this? Standard deviation P. P for population, yes, because we are working with you with populations, not with samples. So use please standard deviation P. And now color your group. And this will be the value. Now, and for second group, again the same. Standard deviation, yes, again use function ST deviation P. And color your group. And this is the value. Standard deviation, this is exactly what we did with you before break today, yes? We calculate standard deviation, yes? It's square root of x minus mu square. So this find the sums and divide it by n. So this is question 3, standard deviation. In this case, it's nothing to do really in question 3, only be careful, yes, and try to find standard deviation for the population. Use function standard deviation P. Any questions? Please ask, let me know that you listen and no questions, or you have questions, please. And something similar you will do again in your lab 7, question 2, and question 3. This is your question 2 and question 3. No idea, yes, type. Now we're going to the question 1, yes, and again going to calculate Q1, Q2, Q3, and so on. Okay. Now, for question 1, what we need to do? Construct box plot. When you will construct box plot, you need to have your original data. Okay, when you calculate 5 number summary, it's better to use frequency distribution. So I'm now going to create my, I don't know, group 3. Group 3 would like to have some different frequencies, yes. So first original data, and we go 11, somewhere 11 will be 33, 5. Okay, this is my original data. Now let's some outlier maybe plus 2. Okay, this is my original data. To do box plot, I need to use original data. And then next will be, okay, box plot. Go to original data and insert, going for your graphs, box and whisker here. And this is my box plot of original data. Okay, I don't have any outliers. I would like to have outliers, so I will change a little bit the graph. Would like to maybe change the data a little bit. What I can put 100 here. I would like to a little bit play with data. So this again, insert, going for this graph box, and now I have my box plot. So to have again box plot, we need to use original data. To calculate Q1, Q2, Q3, you need to have frequency distribution. Frequency distribution. Okay, for frequency distribution, and what we have for frequency distribution, we have our values xi and frequency. And you remember that I ask you to calculate, if you want, of course, quantitative frequency. So now different values of xi, I will try to do this by hand. Will not use function count because small data here, yes, but in general, it's you need to use count if and so on. Okay, 2 then will be 11, 12, 20, 33, 35, and 100. I assume that this is it. Okay, how many numbers I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 numbers. So frequency of 2 is 1, 100 is 1, 11, 2, 12, 2, I assume, 21, 33, 1, 35, 2. So do I have total 10? I will check now. I would like to sum. It's very useful to find the total and see that you have. Sorry, 1 second. Forget word sum. Again, equal sum. Okay, 10. So I did right things. Yes, sum of my frequencies is equal to 10. Now I would like to calculate next column, yes, and then we're going to calculate all our values Q1, Q2, and so on. Okay, first is equal to 1. Next will be equal to sum current frequency and plus previous frequency. Sorry. No, and now if we scroll this down, yes, last number will be 10 here. So we have this. Now we start to calculate all these values. So minimum. To find minimum and maximum, it's better to do, of course, in the original data. So to find minimum, maximum, I need to find. You go to original data, to the original data to find the minimum. To find the maximum, the same, you go to original data, not frequency distribution. No, you can see yourself from frequency distribution if you, or go to the original data and use function max and min. Now to find Q1, first I will do additional calculations. Yes, I need to find n plus 1 over 4. So what it will be n plus 1. N is 10, so I have 11 over 4. 11 over 4. So 275. Okay, we do first Q2 and then return and find value Q. This is, look, 275, it's not Q1, it's X, it's index of X. So I need to check element X 2.75. Yes, and now we will use weights, yes, for these things. So I need to check for Q2, I need to take 11 over 2. And for Q3, if you remember, I need to have 3 multiply n plus 1, 11, and divided by 4. 3 quarters, yes, of n plus 1. No, and now, and next value will be IQR. Next value will be 1.5 Q1, sorry. Q1 minus 1.5 IQR. And next Q3 plus 1.5 IQR. This is what you did, I assume, in the little bit in the previous lab 6. Okay, now we need to investigate a little bit here. Yes, Q1, Q2, and Q3. Look, for example, for Q1. Now a little bit discuss. We'll discuss here a little bit with you. Okay, for any questions, I can see now. Okay, look, to find Q1, my number between 2 and 3. 275 is more close to number 3. Yes, so 75% will be of x3 and 25% will be of x2. Okay, this is the conclusion. Okay, to find Q1, I need to check. Okay, it's close to the, sorry, 275, 1 second, yes, it's close to the x3, it's close to the x3. So 0.75 multiply x3. What is x3? Going to commutative frequency 3. Frequency 3 is in second row, number is 11. So multiply 11 plus 0.25 or 25% multiply by 2, x2. x2 in the same row with 3 because frequency 3. From 2 to 3 we in the row 2, so it's again 11. So Q1 is equal to 11 in our case. To find Q2, we need to take average, yes, average x5 and x6 because 5.5, yes, between 5 and 6. Okay, x5 is 12, x6 you can see the frequency is 20. So 20 plus 12 over 2 in my case. 12 plus 20 divided by 2. So this is Q2. Now Q3. Q3 again. We'll start with smallest number. It's number more close to the age. 75% of xh. H is equal to 35. Correspond to number 35. Plus 25%. x9. 9 is 35 too, so they both 35. So this is weighted formula, weighted formula. So I calculate Q1, Q2, and Q3. Okay, please, any questions? Yes, yes. Did you find, Nikita, did you find my file in the Moodle last time? Did you see this example? No. Last week, yes, okay, last week, yes. Did you see example last week? Okay, thank you, you did. Nikita, where you join the Moodle, where you join the class? Yes, or for the big blue button, yes? It was example for lab 6, yes, last week. And I think I can, okay, I will share this file and put, remove previous and put this. Okay. Okay. Very good. Question 25. Okay, if somebody have questions, yes. Look, how we can when we calculate Q1, we use formula. To calculate Q1, we need to calculate index for x. It's equal n plus 1 over 4. In my case, n is 10, so n plus 1 is 11, 11 over 4. To calculate Q2, I need to take again n plus 1 over 2. To calculate Q3, I need to take n plus 1 over 4 multiplied by 3 quarters. Q1, 1 quarter, 1 over 4, n plus 1. Q2, you can say 2 quarters, 1 over 4, so it's half, yes, 2 quarters is half. And Q3 is 3 over 4, 3 quarters, 3 over 4, n plus 1. This is how we calculate these numbers. And these numbers, it's not Q1, Q3. These numbers give us index for xi. So 275, what does this mean? It means that I need to take from my sequence element x 2.75. I don't have this element, I have only integers. I have x1, x2, x3, yes. I don't have 275. So to find x275, we again use the formula, weighted formula. So 275 close to 3. So I will take this 75% of x3 and I will take 25% of x2. And my x2 and x3 is equal to 11. 2 and 3 element x2 and x3 in the row with commutative 3. And they both 11. And this is how you find here 11. Okay, we go back to the questions. Okay, Nikita. Okay, I will share this file too, yes, and 1 second. We will finish these calculations now, and then, okay, what is IQR? Yes, it's Q3 minus Q1. Q3 is, maybe I put it here, it's equal to Q3, 35 minus Q1 is 11. So 24. Now I'm going to find these values. Q1 minus Q1, 11, minus 1.5 multiply IQR 24. Okay, and this value, Q3 is 35, equal to 35 plus 1.5 multiply IQR 24. So, of course, we can now count, use function count if, yes, we calculate how many numbers we have less than minus 25, greater than 71. Or we can go to our table. No, look. For example, do we have numbers less than minus 25? None. We don't have any of them. And do we have outliers greater than 71? Yes, we have. It's 30. Wait, what I'm talking? It's 100. Yes, not 30. It's 100. So we have one outlier. And look how interesting graph is here. Yes. Why is this interesting? Because I did not work so much with box plot either. Look, we don't have, we have only one viscous. Yes, we don't have second one. And why is this? I can explain you why is this. Because when you remove 100 from my sequence, yes, maximum element will be 35. And when you see my Q3 is equal to 35 too. So No space for viscous. Yes, they coincide. So new maximum element of the set and Q3, they coincide. So it's no viscous here. Yes, it's so maximum is for my new set is 35 and 3 over quatres, yes, of the set is 35 too. So it's box top of the line is top of the box of the rectangle, I mean. Okay, if you would like to count outliers, yes, I did not count, I only investigate by hand. Yes, you can say none and one outlier 100, yes. If you would like to count them, that you need to use function count if and use original set with group 3 count if greater, yes, you remember the set, yes, and then criteria will be less than minus 25. This is for the lowest outliers. And for the highest outliers, you can use function count if, yes, again, original set, and criterion will be greater than 71, yes, and it will give you 100. Any questions? Guys, please ask if you have any questions. Yes, it's last few minutes. And please at home try to finish tutorial 6, and because it's now tutorial 7 is available to, we'll go through the tutorial 7 next time.